All right, folks. So we've talked about thrust, and I sort of want to talk a little bit now about what is happening when your kite. Let's say here's a kite. I don't know why I keep making these like the stereotypical kite. So you have your kite. Here's your bridle. Here's your line, and there's a person down here holding on to it, presumably you. How is it that the kite is able to go up in the air? Where does the force that lifts the kite up come from? When we talk about an aeroplane, generally it's from the way that the wing goes through the air. I'll show you like an airfoil. It creates an area of low pressure underneath here, and air like goes in here and pushes up, where it like sucks a lot of air into that cavity and creates a pressure up. You have rockets that we did. Remember, we did rockets. This is a very poor looking rocket. Uh, Getting its lift mainly right straight from the materials that also gave it thrust. Same thing, going up in the air like that. Um, the kite, though, generally is going to get its thrust by the sail. So this is the sail. This is the either fabric or plastic or whatever. And I think of it kind of like um, first of all, you can think of it, it's called a sail. You can think of it like a sail on a sailboat. So you unfurl the big sail, it catches the wind, and the wind propels it because all of this wind is smashing into the sail and pushing the boat along, right? That's what's happening. Well, in this case, the wind is coming in, it's being caught, sort of like a net catching the wind. And if the kite is at the right angle, then it will push the kite up. So instead of pushing it backwards, which is what is counteracting the thrust that the person puts this way, it will hopefully push it upwards. That's the whole idea, right? So if you have lots of wind, here's one of the keys here. So if you have a high wind that's blowing really hard, you want an angle of attack, let's say like this with your kite. So the kite is very flat. So this is a low angle of attack. And in this case, so you'd have a very like you'd adjust your bridle as such so that the kite would be almost flat because you have really, really, really high wind, right? So the wind is really blowing very dramatically, and it really wants to push that kite up really hard. So you would basically allow the kite to be almost flat and cut through the wind and only pick up a little bit of it to push it upwards because that's all you can handle because the wind is really high. So if there are 20-mile-an-hour winds, you don't want to be ripping your kite apart or not being able to hold on to it. If the wind is really light, like there's not very much wind, I'm going to do this in yellow. So there's not very much wind. You're going to have your kite like almost straight up and down because in this case, you want that kite to collect as much air, as much wind as possible, and get in this net and keep the kite aloft. Like you're not even as worried about getting it way up in the air. You're worried about keeping it able to be aloft. So that is also one of the reasons that you have a bridle that you can adjust these. Sometimes you can adjust them on the fly. Sometimes you have to bring the kite down and you adjust it for the wind conditions. But it is important. The bridle here is like a bridle on a horse. This part right here. That's why your line doesn't generally just go up and connect to the kite. You make it have at least two spots. I've heard of them being dozens of spots in order to adjust and get the kite exactly the way that you want it looking. Um, and you end up grabbing the lift off of that wind pushing up. Now, what is the lift doing? The lift is counteracting the weight. So the weight of the kite, I'm going to do this in purple. The weight of the kite obviously is pushing down, and obviously, essentially, the weight's going to be the same for the same kite no matter what the wind conditions are. Which is why you have to change the angle of attack on the kite, because if the weight's always the same, if you get a big gust of wind, the kite's going to go up as high as it can, and maybe get ripped apart. When the wind is low, the kite is not going to generate that much lift. It has to counteract that weight. So the weight obviously is generated by gravity. It's the weight of the kite pulling, wanting to come back down. So the wind, you have to have a kite that's light enough with a big enough sail to catch enough wind to counteract the weight of it, the force of gravity pulling it down towards the earth. That's sort of the essentials of that. So you're turning this wind into lift. Now, if the wind wasn't blowing, let's say you go out there and you're trying to get your kite up in the air and the wind's not blowing, you can generate like fake wind. And we do that by generating thrust by running, right? That's what we sort of talked about in the thrust thing. I can take off running and have the kite out here, and I'm like generating wind by running through the air. So sort of like I could generate wind by driving my car through on the road and put my arm out the window, and now I'm moving faster than the air, and I'm sort of creating wind by doing that. So at any rate, that is where you get lift from for a kite, and you're overcoming the forces of gravity. That's what you're counteracting in order to keep this kite up in the air and keep it aloft. Let's go here.